उम्मीद है आप लोग बिल्कुल ठीक है. It's all going great and you're having a great life and you're learning something new from me. Thank you so much. And today I came back with mathematics, so you can see that 3 days I just make you revise about maths, then one day English, then again maths, because nowadays I want to clear your concept about fractions in maths. But let's see what's new in it. So but basically I can give a hint that today we're going to do the reinforcement of the fractions. Like whatever we discussed in the fractions, we have to do the reinforcement of that. So first of all, we will start our day by starting dua for knowledge. Bismillahirrahim. Rabbi shrah li sadri wa yassir li amri wahlul uqdatam min lisani yafqahu qawli. Rabbi zidni ilma. Eh mere Rabb, mere ilme izafa farma. So today we're going to basically do the revision of all the topics. So very first thing we discussed about fraction was what is a fraction. So you should know what's a fraction, what do we call a fraction. So basically I told you that a fraction is a part of a whole when whole is divided into equal parts. So whenever you're going to have a part of a whole, like here I'm having 4 total parts and 3 of them are shaded, and that are also equal in, they are square shaped, maybe, yes, they are square shaped, and they're also equal. So that means fraction is a part of a whole when whole is divided into equal parts. Now if I want to write the fraction of these shaded parts, so first of all, shaded parts, so I have to write in numerator I'm going to have number of shaded parts and our total parts. Okay, so I'm going to have the fraction total shaded parts are 3 and total parts are 4. So 3 over 4 is my fraction. If I want to write my fraction in words, I'm going to write 3 quarters. Okay, because quarters means 4. Okay, then if I have to write the fraction of unshaded parts, for that I have to write in the numerator would be number of unshaded parts over total parts. Okay, so if I have to write that fraction, so the unshaded parts are 1 and total parts are 4. So 1 over 4 is a fraction, and you can also see it's also a unit fraction, isn't that? So if I have to write a fraction to words, so I'm going to write 1/4. Why I'm not putting s over here? Because whenever we are having one here, so we never put s here, because one is a quantity of less things. Then we learned about the types of fraction, and I told you that there are 2 types of fractions, that are proper fraction, improper fraction. Proper fraction are those fractions whose numerator is smaller than the denominator. That means denominator is always greater. For example, 1 over 4, 3 over 5, 7 over 8. In these, the numerators are smaller than the denominators. Like in this case, we're having also a unit fraction. Unit fraction basically means whenever your numerator is 1, so like 1 over 6, 1 over 10, because we never put the 0 in the fractions. Like if we put, but not in the denominators, we don't use to put, because it's not a divisor. So then that's why, because every number is greater than 1 except 0, so that's why it's going to be a proper fraction. So then we're having an improper fraction. What did I said you were, what we do in an improper fraction? In improper fraction, maybe in numerator and denominator they are equal in value, or numerator is going to be greater than the denominator. Like look at the example, 7 over 7 here, they are equal in value, and 9 over 2 here, the numerator is greater than denominator. That means it's improper, it's not real. So in this case we're having a mixed number. What did I said you was a mixed number? Whenever we're having a combo of whole number and a proper fraction, we are going to say it's a mixed number. Like here I took example like 3 whole 5 over 9. So here this is a mixed number, and we can change a mixed number into improper fraction and an improper fraction into mixed number. So let's convert the mixed number into improper fraction. Like 3 here, these two fractions would be multiplied and this would be plus. So 3 multiplied by 9 equals to 27. 27 plus 5 equals to 28. 9, 30, 31, 32. So 32 over 9 is the answer. That is a improper fraction. Then here I am having another example, 1 whole 3 over 4. So we are going to do the same. I'm going to multiply this and add this, like 1 multiplied by 4 equals to 4, and plus 3, 5, 6, 7. So 7 over 4 is the answer, and it's an improper fraction. So let's convert the improper fraction into mixed number. So you have to convert 4 over 9 into a mixed number. So for that, what you have to do is you have to do the division. So what did I tell you? That when whatever we are having the numerator, that's going to be the dividend, and whatever we are having in the denominator, that's going to be the divisor. So 4 here is a divisor, 9 is a dividend. So let's multiply them. Look, divide them. So we have to check that is there in four table where are we having 9, so we are not having 9, we're having 8, and we have to check for the least. So 4 twos are 8, and then we have to subtract that we are having 1 as the remainder, 2 as the quotient, 4 as a divisor. So 94, and we have to change into QID form. Q means quotient, R means remainder, D means divisor, so that equals to 2 whole 1/4. Then we're having conversion of mixed number into improper fraction. How we can convert a mixed number into improper fraction? You have to convert 2 whole 3/4 into improper fraction. So what does 2 whole 3/4 means? Basically that means 2 wholes and 3/4. So like do first way pictorially. Okay, you're going to make 3 pictures. Take a 3 holes that are representing 4 equal parts, and 2 holes that are completely shaded, and the third one is shaded, that's having 3 equal parts, 3 parts that are shaded. So that means 4 plus over 4 plus 4 over 4 plus 3 over 4. Denominators are same, just put the denominators and then add the numerator. So you're going to have 11/4. Or if you want to do another way, like 2 whole 3/4 like this, so you can have to multiply these fraction and add these fraction, like 2 multiply by 4 equals to 8 plus 3 equals to 11. So 11/4. So the 2 whole 3/4 equals to 11/4 with any way you can do. Then we learned about like and unlike fractions. So what are like fractions? So like fractions are those fractions that are having the same denominator. Whenever you're going to have a look at the fraction that's going to have same denominator, you can find the same denominator in these fractions that are like fractions. Like I'm having a figure that's having 3 equal parts and 3 of them are shaded. On the other hand, I'm having a figure that's having 3 equal parts and 1 of them is shaded. First figure show us 3/3 and second figure show us 1/3. So that means here if you look at the denominator, so denominator is the same, we have no interest in numerator, whatever is the numerator. So the denominator is the same, that means these fractions are like fractions. Let's come to the unlike fractions. What are unlike fractions? So unlike fractions are the fractions that are having different denominators. Okay, whenever a fraction is going to have a different denominator, you're going to say this is the unlike fraction, this is a not real fraction. So here I'm having a example, like a figure that's having 4 equal parts and 3 of them are shaded, that show us 3/4, and then a figure that's having 2 equal parts and 2 of them are shaded, that show us 2/2. So it doesn't matter that whatever is the numerator, we have to look for the denominator. Here 4 and 2 are different denominators, so that means they are different denominators, so of course it's going to be unlike. Like and unlike both are the opposite of one another. Equivalent fraction. So what is the equivalent fraction? What did I tell you? Equivalent fraction are direct fraction that represent the same amount even though they may appear different. So even though if their representation is different, even though amount they are showing is different, but if the way when we multiply them, the way we divide them, we're going to get the same answer. That means they're equivalent fraction. So fractions that are equal in value are always called equivalent fraction. Here I'm having a figure that's having 1 whole and 2 whole, and here 2 parts are present and one of that shading, that means 1/2. Then we're having a figure that's having 1 whole that's having 4 equal parts and 2 of them are shaded, that means 2/4. Then a figure that's having a whole that's having 6 total parts, 3 of them are shaded, and a whole that's having 8 equal parts, 4 of them are shaded. Now what we have to do is we have to check that are these figures equivalent to each other. For that we have to multiply. So let's multiply. 2 multiplied by 2 equals to 4 plus 1 multiplied by 2 equals to 2. 2/4. Yes, this is equivalent. Then 3/6. 2 multiplied by 3 equals to 6. 1 multiplied by 3 equals to 3. Then 3/6. This is also equivalent. 4/8. 2 multiplied by 4 equals to 8, and 1 multiplied by 4 equals to 4. 4/8. That means these all fractions are equivalent fractions. And other way, may I tell you, that's the easiest way you can find out. If you are not finding out that like this, so you have to look at the each figure. If they're representing, look, this half part is shaded, we does not look at the thing what the amount are they carrying, we just have to look at these parts. And you can also see the whole is also equal, so this also show us this thing. Look, here I'm having an activity like you have to find two equivalent fractions of 9/5. So you have to multiply the numerator and denominator of given number with any non-zero number. Non-zero number means not like the number that's not having 0 inside, like 10, 20, 0, 30, 40, like any number that's having no 0 present, right? This 15 is not having any 0, 5, 6, 7, 8, 9. these numbers are not having any zero, so the non-zero numbers means this. So here I'm having 9 over 5, so the easiest I can do is I can multiply this by 2. So 9 multiplied by 2 equals to 18, and 5 multiplied by 2 equals to 10. 18 over 10. Now let's leave 3 and 4 and let's come to 5, because 5 is also easier. So 9 multiplied by 5 equals to 45, and 5 multiplied by 5 equals to 25. So that means 18 over 10 and 45 over 25 are the two equivalent fractions to 9 over 5. Okay, it does not matter. Just giving you the hint that you do not have to use any non-zero number, except that any number you want to use, you can use. Okay, but I want to choose these numbers 2 and 5. That's why I choose them, because they were easy for me. Okay, now here we're having test your knowledge. You have to do what does these figures represent, are the equivalent fractions or not. So first of all, you should know these equivalent fractions represent the same amount or size of the shaded portion of a whole. So without solving this very easily, I can get to know, because they are holding same amount, the half is used and circle is also same, so I can easily know that yes, they are equivalent fractions. So there is no proper need of working. If they are not asking, no working needed. If they're asking, then of course you have to do. So you have to test it. Okay, first. Okay, G. So you have to check the simplified form of the fraction. If they're equal, then the fractions are said to be equivalent fractions. So if the simplified form, first we have to make it a simplified form. After that, we have to check for that it are equivalent or not, because they may carry on some other amount. Okay, so here we're having our 2 over 6 and 4 over 8 equivalent to each other. So you have to compare the simplified form of the given fraction. So first of all, you have to check for the simplified form. Okay, 2 over 6. So you have to divide this by 2. That gives me 1 over 3. And then 4 over 8. That are also divided by 4. So divide it 1 over 2. So a little bit difference of one number. A difference of one number. Okay, so that's why they are not equivalent. So they hold a different value. So they are not equivalent fraction. So then we have to test again. This thing comes because you have to check for these things. First of all, you have to check for equivalent things. Okay, first of all, you have to simplify that, and then you are allowed to do equivalent fractions. So before that, you cannot do. If they are not simplifying, then do that. If they're simplifying, first simplify, then do this method. So are 15 over 21, 25 over 35, and 5 over 7 equivalent to each other? So you have to compare the simplified form of the given fraction. So first of all, here I can see 15 and 21 and divided by 3, I'm getting 5 over 7, and 25 and 35 are divided by 5, I'm getting 5 over 7. 5 over 7, it's not any form that we cannot convert it, the reduced forms of 5 over 7. So here I can see these all fraction holds 5 over 7. That means yes, they are equivalent fractions. So this is a basic case that you use. You can see here they are also using division, isn't this? But I was using multiplication, so it's your choice. Any way you can use. So addition of fractions. So what? Let's do the pictorial addition. So you have to add 2 over 4 and 1 over 4 pictorially. Okay. So that is basically you have to make two holes, not two holes, two triangle shapes that are having 4 equal parts. Okay. In two would be shaded, and in one would be shaded. Then because 2 over 4 and 1 over 4 you are having, then you have to add. You have to combine all the colored parts. So I'm having this figure that gives me 3 over 4. So this 3 over 4 is my answer. But if I'm doing subtraction of fractions, so you have to subtract 1 over 4 from one whole pictorially. So that is, first of all, you're going to make a same triangle, and that's having 4 equal parts, and 4 of them are shaded in the. Then you're going to have 4 equal parts, one of that is shaded. Then you have to take away, I have to cancel the common shaded. So 1 over 4 minus 1 over. So what you have to do is totally going to have a whole. Take it, and you have to deduct one whole from it. So I'm having 3. So 3 over 4 is going to be my answer. So I want to tell you important thing. Don't forget this thing. Order of numbers or fractions in addition and multiplication does not matter, but order of numbers and fraction in subtraction and division matters a lot. So whenever you're doing multiplication or addition, the order does not matter, but if you're doing subtraction and division, the method matters a lot, because in division you can write the denominator, you can write the dividend at divisor at the dividend place, it's going to give you wrong answer. And in subtraction, if you write the bigger amount at second and the larger amount the smaller amount at the first, so it's going to not multiply, it's not going to be subtract. So that's why an addition answer is going to be same and multiplication answer is going to be same, so that's why there is no proper need of the matter. So multiplication of fraction. So first of all, you should know multiplications are repeated addition. So whenever you're doing multiplication, you're doing addition same as. So if I say you have to multiply 4 multiply by 1/3, that means 4 group of 1/3. So we are going to put 4 groups that are having 3 equal parts, and one is shared in all of them. That means 1/3, 1/3, 1/3, 1/3. Okay, that means 4 multiplied by 1/3, that means 4 times 1/3. Okay, so when you have to combine all the parts, so here this would come here, this would go here, and this was going to come over here. So this is the pictorial representation that gives me, what does it gives? 1 whole 1/4. Okay, then we're having example like you have to add 2 wholes and 3/4. So 2 plus 3/4 equals to, first of all, make 2 into a fraction, that means 2/1 plus 3/4. Then we cannot add 2 or more unlike fractions. So first of all, you have to make them equivalent fractions, and for that you have to take the LCM of 1 and 4, that is 4. So you have to multiply 2/1 with 4 and 3/4 with 1. Okay, so we're going to have 8/4 plus 3/4. Then denominators are same, multiply the numerator, add the numerators. You're having 8 plus 3, that equals to 11. So 11/4 is the answer. It's an improper fraction, so convert into mixed number QRD form. 2/4 is the answer. And here you have to subtract 2/6 from 3/4. So 3/4 minus 2/6. Why? Because I order matters a lot. The greater value would come at first, like 3/4. So you first of all, they are unlike fractions, so we have to first of all convert them into equivalent fraction. For that we have to convert them into like fractions. So we have to take the LCM of 4 and 6, that is 12. So for 3/4 is going to multiply by 3, and 2/6 is going to multiply by 2. So I'm going to get 19/12 minus 4/12. Now denominators are same, subtract the numerators, 9/4, so that is gives me 5/12. So it's the answer, and it's simplest form, and it's also a proper fraction. Now you have to test your knowledge, like which fraction is greater, 2/6 or 3/4. Yes, 3/4 is a greater fraction. Then you have to solve 1 whole 4/5 multiplied by 7/12 of 18/30. What you have to do is you have to first of all convert these mixed number into improper fraction, and then you have to convert off into the multiplication sign. Take off basically means multiplication. So 1 multiplied by 5 plus 4 equals to 9/5, and then 7/12 remains same, 18/30 remains same, but here 7/15 of 18/30 is going to be 7/15 multiplied by 18/13. Then you have to check for all the possible simplifications. So first of all, listen to me. Important point. One simplification at one step. At one time, we can only do simplification of two numbers, that is numerator and one denominator. So you cannot do the simplification of two numbers at one time. At one time, you can do of only one. So you have to check for proper possible simplifications. So here you can see 9/5 multiplied by 7 multiplied by 18/30. Here you get to 9, 12 and 18 are divided by 6. So divide, I'm going to get 9/5 multiplied by 7/2 multiplied by 3/30. Then here I see 3 and 30, they both are divided by 3. So divide them, I'm getting 9/5 multiplied by 7/2 multiplied by 1/10. So here now more possibilities possible. So we have to multiply the numerators with numerators and denominators with denominators, and you have to simplify if that's possible. So here I'm having 9 multiplied by 7 multiplied by 1 over 5 multiplied by 2 multiplied by 10. So I'm going to get 63/10. Then it's going to be simplified. So then you have to multiply this fraction with 1 and 10. So we're going to have 63/100, and it's a proper fraction and no more simplification. So it's time for your participation. So you have to write which one of the following solution is correct. So solution A or solution B. So if you look at the solution A, it's giving us 15/4 minus 1/6, and here 15 and 6, they both are divided by 5 and 2. So they're giving us 5/4 minus 1 over 2 and 5 over 5 minus 1 and 4 minus 2 and 4 over 2 equals to 2 wholes, and I don't know what's is happening. It's wrong because they have not make the denominators like fraction, so it's absolutely wrong. So let's look at the solution B. So whereas in solution B, 15 over 4 minus 1 over 6, so 15 over 4, this fraction is multiplied by 3, and 1 over 6 is multiplied by 2. That gives us 45 over 12 minus 2 over 12. Then denominators is same. They have subtracted the numerators. 45 minus 2 equals to 43 over 12. It's improper fraction. They converted to mixed number 3 whole 7 number. That gives me that solution B is correct. So here solution B is correct. So are 15 over 6 and 4 over 10 equivalent to each other, yes or no? So for that we have to do working. So 15 over 6 and 4 over 10. So first of all we have to make them, we have to check that if they are simplify or not. So we have 15 over 6 divided by 3 and 4 over 10 is divided by 2. So in 15 over 6 I get 5 over 2, and in 4 over 10 I get 2 over 5. That means that is the opposite, it's a reciprocal. So that means no, the answer is wrong. So the no is the answer. So you have to match the column A with the column B and have to write your answer in column C. So I'm having 1 over 4 multiplied and 7 over 3. What are these? These are unlike fractions. You have to subtract 1 over 3 from 7 over 3. How are you going to do that? Because yes, 7 over 3 is going to come first minus 1 over 3, because what did I said, the order matters a lot in subtraction. Then we're having 2 over 3 and 5 over 3 that are like fractions, denominatorless, and then having a figure that's having two holes and one hole is full shaded and another hole is having 4 equal parts and 3 of them are shaded. That makes me say that this is a mixed number. Okay, groups of 4 groups of 1 over 5, that means 1 over 5 multiplied by 4 times. So that means this is the answer. So I hope so you like today's lecture. I will see you in the next lecture. Till that, Allah Hafiz. Take care of yourself. Goodbye. Allah Hafiz.